Here we are on section D, and this section comprises of long answer type questions of 5 marks each. Let's get started with the first one, part A. And it's given that A and B matrices are given. We have to find AB and then use it to solve the following system of equations. That is, first find out the product of A and B. So let's write down the A matrix. So this is minus 3, minus 2, 4, 2, 1, 2, 2, 1, 3. So this is A, and now B is equal to 1, 2, 0, minus 2, minus 1, minus 2, and 0, negative 1, 1. We have to find the product. So let's find the product AB. And so this is first row and first column. Minus 3 into 1 is minus 3, negative 2 into negative 2 is plus 4, minus 4 into 0 is 0. First element, and minus 3 into 2 is negative 6, plus 2, plus 4. Minus 3 into 0 is 0, minus 2 into minus 2 is plus 4, and negative 4. This is the second row and first column, so 2 into 1 is 2, 1 into minus 2 is minus 2, 2 into 0 is 0. So plus 0 now, 2 into 2 is 4, 1 into minus 1 is negative 1, 2 into minus 1 is negative 2, 2 into 0 is 0, minus 2, and 2 into 1 is now third row and all the columns. So 2 into 1 is 2, 1 into minus 2 is minus 2, 3 into 0 is 0, 2 into 2 is 4, 1 into minus 1 is minus 1, 3 into minus 1 is minus 3, 2 into 0 is 0, 1 into minus 2 is minus 2, plus 3. Okay, so this is now minus 3 plus 4 is 1, so this is 0 and 0. Okay, so this is 0, 4 minus 1 is 3, minus 2 is 1, this is 0, 0, 4 minus 1 is 3, minus 3 is 0, and this is 1. Okay, so we have got AB. Okay, so which is an identity matrix? So that means A and B are, so A and B are convertible matrix because the product of them is an identity matrix. So A and B are convertible matrices. And when A and B are convertible matrix, that means they are inverse of each other. So A inverse is B and B inverse is A. So that is the result we got from the product. And now we have to use this concept to solve these equations. And let's write down the given system of equations are. So given system of equations are, first is x minus 2y is equal to 3. And then 2x minus y minus z is equal to 2. 2x minus y minus z is equal to 2. And then it's minus 2y plus z is equal to 3. So minus 2y plus z is equal to 3. And these given of system of equations, these can be written in the form. These equations can be written in the form. So this is Cx is equal to D, where C is, so C matrix is 1 minus 2 0 and 2 minus 1 minus 1. This is 0 minus 2 and 1. So this is C, and X is equal to, so X or so these matrices can be written in the form Cx is equal to Z B and X is equal to C inverse D. Now let's write down the C matrix. So C matrix is 1 minus 2 0 and 1 minus 1 minus 1. This is 0 minus 2 and 1. So we have to get the inverse of this into D matrix is 3, 2 and 3. Okay, now if we have a close look at the C matrix, that is 1 minus 2 0 and B matrix. So if we check the B and the C matrix, so this is C and this is B. So both these are, so C matrix is actually the transpose of B. So C matrix is 1 minus 2 0, 1 minus 1 minus 1 0 2 0. So C matrix is actually the transpose of B. So instead of C here, I can write B transpose and then inverse into B. Now this B transpose can be written as B inverses transpose. So this is transpose, and C is equal to transpose of B. So instead of C, I have written B transpose, and B transpose inverse can be written as B inverse transpose. Now B inverse is equal to A. So instead of B inverse, I can write the A matrix, and A matrix is, this is minus 3 minus 2 minus 4 and 2 1 2 and 2 1 3. So this is the B inverse. So B inverse is equal to A. So instead of B inverse, I'm going to write A and then use the transpose. So it has to be the transpose here. So this is A transpose into D. So this is A, and we will do its transpose and then multiply it with D. D is 3, 2 and 3. So that's how we are going to use this result. So I have just written here to show that this C matrix, this one, is the transpose of B. So instead of C, I have written B transpose and then its inverse. And now B transpose inverse can be written as B inverse transpose. So B inverse is A. So it's A transpose into D, and A is 3 minus 2 minus 4. So let me do its transpose now. So it's minus 3, 2, and minus 2, 1, 1, and minus 4, 2, 3. So this is now the transpose of A. We have to multiply it with 3, 2, 3, and that will give me X. X is X, Y, and Z. So this is X. Okay. So let's multiply this, and this is minus 3 into minus 3 is minus 9. 2 into 2 is 4 plus 6. Next one, plus column. So minus 2 into 3 is minus 6 plus 2 plus 3, and it's minus 12 plus 4 plus 9. And this is X, Y, and Z. Okay, solve this. This is minus 9 plus 4 is minus 9, minus 5 plus 6 is 1, minus 6 plus 2 is minus 4 plus 3 is negative 1, and minus 12 plus 4 is negative 8 plus 9 is 1. Okay, this gives me X is equal to 1, Y is equal to negative 1, and Z is equal to 1. So these are the values of X, Y, and Z. And that's how we use the product to get these, show that the matrices are convertible and A inverse is equal to B, B inverse is equal to A. Now these equations, write them in the matrix form, which gives me X is equal to C inverse of B, and C is actually the transpose of B. So we have written, instead of C, it's B transpose, and B transpose inverse is B inverse transpose, so B inverse is A. So B inverse is A, so A transpose into D, write down A, transpose it, and multiply it with D, which will give us the value of X, Y, and Z. Okay, now let's move on to the next part of this question. And first of all, I'm going to erase this. Okay, for the part B, it's given that function f alpha is in terms of matrix. So it's given that f alpha is equal to cos alpha minus sin alpha into 0 and 0. So this is sin alpha cos alpha 0 and 0 to 0 1. Okay, we have to prove that f alpha into function of beta is equal to f of alpha minus beta. So let's first find out f of alpha minus beta. So f of alpha minus beta is nothing but we have to replace this alpha with alpha minus beta. So this is cos of, this is our RHS. So RHS is f of alpha minus beta. This is cos of alpha minus beta minus, it's minus sine of alpha minus beta, it's 0. So this is sine of alpha minus beta cos of alpha minus beta 0, 0, 0, and 1. Okay, let's keep it as a set of equation. Now let's multiply f alpha into f minus beta. So f alpha is given. So f alpha into function of minus beta is equal to f alpha is its cos alpha minus sin alpha 0 upon sin alpha cos alpha 0 and 0, 0, and 1. Okay, now minus beta is cos of minus beta minus sine minus beta 0 sine of minus beta cos of minus beta 0, 0, 0, and 1. Okay, now we have to multiply this, but before that, let's just simplify this. So our first matrix is cos alpha minus sine alpha 0, and this is sine alpha cos alpha 0, 0, 0, 1. Now this is cos of minus beta is cos beta. We know because we know that cos of minus x is cos x, and the sine of minus x is negative sine x. This is cos beta, and minus sine of minus beta is minus sine beta, minus minus is plus. So this is sine beta 0, and this is negative sine beta. This is cos beta is equal to 0, 0, 0, and okay, now let's multiply this. So this is called cos alpha into cos beta, and minus sine alpha into minus sine beta is plus sine alpha into sine beta. 0 into 0 is 0. So cos alpha into sine beta, this is cos alpha into sine beta, and minus sine alpha into cos beta. And 0 into 0 is 0. So cos alpha into 0 is 0. Sine minus sine alpha into 0 is 0. 0 into 1 is 0. So this is 0. Okay, next one, next row, minus sine alpha into, this is minus sine alpha into cos beta, and minus cos alpha into sine beta. So sine alpha into cos alpha into minus sine beta, 0 into 0 is 0. So sine alpha, next one is sine alpha into sine beta plus cos alpha into cos beta and then 0. So this is also 0. Okay, now 0 into cos alpha is 0, 0 into sine alpha is 0, 1 into 0 is 0, so this is 0. And 0 into sine beta, 0 into cos beta, 1 into 0 is 0, and 1 into 0 is 0, 1. 0 into 0 is 0, 0 into 0, 0, 1 into 1 is 1. Okay. Okay, now this is of the form cos A cos B plus sin A sin B, which is equal to cos of A minus B. And for this, we can take negative common. So if negative is common, then this term is positive. So this is sine alpha cos beta minus cos alpha sine beta into 0. Now this is sine A cos B minus cos A sine B, which is sine of A minus B. Sine A sine B plus cos A cos B, which is cos of A minus B. This is 0, 0, 0, and 1. Okay, so finally this is cos of alpha minus beta, and this is minus sine A cos B, so this is negative of A sine of A minus B, 0. This is sine of A minus B cos of A minus B, 0, 0, 0, and so this is F alpha into F negative beta. And if we compare this with F of alpha minus beta, so this is F of alpha minus beta, which is cos alpha minus beta minus sine alpha minus beta, 0, sine of alpha minus beta, cos of alpha minus beta. So from 1 and 2 you can write. So from 1 and 2 you can say F of A into F of negative beta is equal to F of alpha minus beta, and hence it is. And this solves our question number 32, both the parts. And let's move on to question number 33.